Okay, so in this arithmetic sequence question, we've been given some information about an arithmetic sequence, but we haven't been told the values of a and d, which is what we actually have to try and find in the question. So I'm going to start by writing down my formula for the general term of an arithmetic sequence, which is a plus n minus 1 times d. And we're told that the sixth term is half the first term. So term 6 is equal to half the first term. So how could we find term 6 in terms of a and d? Well, we'll sub 6 into the general formula. So we have a plus 6 minus 1 times d. So that's term 6. And that's equal to half the first term. Now we could sub n equal to 1 into that formula, but half the first term is a, and so half of the first term is just half of a. I'm going to tidy it up by say a plus 5d equals a half of a. And then I'm going to multiply both sides by 2 to give me 2a plus 10d equals a. And then subtract an a from both sides to give me a plus 10d is equal to 0. And I'm just going to label this. So we're then told that the sum of the third and 10th terms is 27. So they don't say the sum to 3 terms or the sum to 10 terms. It's the sum of the third and the 10th term. So again, we're going to use the general formula for an arithmetic sequence, and we're going to say that the sum of t3 plus t10 equals 27. So t3 we can find by subbing 3 into our general formula. So we have a plus 3 minus 1 times d, plus t10 we'll sub in 10 into our formula. So a plus 10 minus 1 times d, and this will be equal to 27. So we have a plus 2d plus a plus 9d equals 27. A and a is 2a, and 2d and 9d is 11d, and this is equal to 27. And I'm going to label this equation 2. And so we have two equations in a and d, and so we're going to solve this system of simultaneous equations. So solve the simultaneous. So I'm going to take equation 2, and I'm going to write that one first. So 2a plus 11d equals 27. And it's a good idea, just label your equations so that if you have to go and check your work later on, those labels will help you navigate back through the work and see where you might have made a mistake. Equation 2 then, I'm going to multiply by minus 2 so that I can eliminate the a's. So I have a times minus 2 is minus 2a, 10 by minus 2 is minus 20d, and then 0 times minus 2 is obviously still 0. I'm going to draw a line underneath and then sum the lines. So 2a minus 2a is 0. We have 11d minus 20d is minus 9d, and this is equal to 27. If minus 9d is equal to 27, divide both sides by minus 9, and we get d is equal to 27 divided by minus 9, which is minus 3. And so the common difference in this arithmetic sequence is minus 3. I'm going to sub this value of minus 3 back into equation 1. So we'll once again write equation 1. We go up here, and we have a plus 10d is equal to 0. So a plus 10 times minus 3 is equal to 0. So a minus 30 equals 0. And so a is equal to 30. And so we can see our arithmetic sequence starts at 30, and then it goes down 3 each time. So 30, 27, 24, and so on. Now, part 2 of the question asks me how many of the terms in the sequence are positive. So we can see it starts at 30, it's going down 3. There will be a time when we get into negative numbers, and we want to know how many of these numbers are positive before the sequence continues on through the minus numbers. So I'm going to write down the formula again for the general term of an arithmetic sequence, which is Tn equals a plus n minus 1d. I know now that a is equal to 30, so I'm going to sub that in. Plus, I also know that d is equal to minus 3. And tidying this up, I get 30 minus 3n plus 3, and that gives me 33 minus 3n. And so this is the formula for the general term. So this formula will allow me to find terms of the sequence. I'm interested in positive terms of the sequence, so I'm only interested in values of n that would give me positive numbers here. So 33 minus 3n, I need to be a positive number, which means greater than 0. I'm going to add a 3n to both sides to say 33 is greater than 3n. Divide both sides by 3 and I get n is less than 11. So this tells me that all of the terms that are less than 11, so all the terms up until the 11th term are positive, and so there is 10 positive terms in this sequence.